We know that block diagrams and signal flow graphs are two different methods of representations of control systems. Now we can see there exists a conversion from block diagram to signal flow graph and signal flow graph to block diagram. In general, the process of solving problems or obtaining the transfer function using block diagram rules are difficult when compared to signal flow graph. Now we will see how to convert given block diagram into a signal flow graph and see how can we obtain the transfer function. Now, what are the steps to be followed to convert the block diagram into signal flow graph? We know that in any block diagram, we have blocks, summing points and takeoff points are available, and input is available and also output is available. Now, so we have to take at each input and output, assume one node or assign nodes to input and output. This is the first step. The next is at takeoff point and also after the summing point we have to assign nodes. Next, whenever there are blocks connected together or two blocks are adjacently connected, in between we need to assume one node. And two summing points are connected together, then we should combinedly take one node. And whenever two takeoff points are connected together, again we should take combinedly one node. There is certain situations where takeoff point and summing points are adjacently connected. Now when these two are adjacently connected, let us take the first case. Takeoff point is connected after the summing point. So when takeoff point is connected after the summing point, we should take the combination as one node. But when takeoff point is connected before the summing point, then two nodes separately we need to assume. So after assuming all the nodes, after assigning all the nodes, now we connect whatever the block diagram fashion is available, we should connect in the signal flow graph. And the gains of the blocks also we should represent as a transmittance and the branches, and the directions also we should take it. One more important thing here is in the conversion, whenever you have negative feedback, then the negative value or the negative polarity we should assign to the corresponding branch transmittance. So after taking care about the directions, after taking care about all the polarities, then we can get the signal flow graph for any given block diagram. Having understood the concepts of block diagrams and as well as the signal flow graphs, we can compare block diagram technique and as well as the signal flow graph technique. Now the comparison goes like this. So here I can say it's the block diagrams, the other side we have signal flow graphs. So in block diagrams, the primary importance is given to the elements and their transfer functions. Whereas in signal flow graph, the primary importance given to the variables and their connections. Next, so in block diagram, each unit is represented as a block, whereas in signal flow graph, each unit is represented as a line segment. Next, so in block diagram, summing point and takeoff point both are represented separately, whereas in signal flow graph, your summing point, takeoff point both are represented as a single node. There is no difference in the representation in signal flow graph. And in block diagram, there is no concept of self loop, whereas in signal flow graph, the concept of self loop can exist. Now in block diagrams, there is no unique way of finding the solution in block diagram because it is a rule based. While solving the problems, you can follow any method. You can shift the summing point, you can shift the takeoff point, you can change the blocks one another. You can do any type of method of solution in block diagrams. Whereas in signal flow graph, you have a systematic way of approach to find the transfer function, and so it is a systematic way of and it is a formula based. Signal flow graph is basically a formula based solution. Similarly, from block diagram, we already seen, we solved some problems. From that we can conclude that block diagram method is a time taking method, and it is very tedious to solve the problems or to find the transfer functions. The counterpart in signal flow graph, it takes less time, and the solution what we obtained is very easily. These are the comparisons of block diagram technique and as well as the signal flow graph technique.